So as I said, the last lesson in this chapter is on something called waves, actually dealing with functions that we have dealt with a little bit this year, and I'm sure you have dealt with um, in previous years. So I did decide to split this into 2 days. I think that was better. So we'll do waves today. There'll be a lesson on waves Thursday. Friday, we will have a review assignment. Monday, um, if you have questions on the review assignment, we'll still do attendance, but I will answer any questions on the review assignment. And then by Tuesday, you will have your test completed for this set of lessons. Excuse me. All right. So waves. Some terminology to start with. The waves that we're talking about are going to be sine waves. And so there are bits of terminology that we're going to use to make things a little more streamlined. Amplitude is the height of the wave. A bias is a shift up. The period, which is usually abbreviated with T, is the length of time it takes a wave to repeat itself. Very closely related to the period is the frequency, sometimes called the angular frequency. Frequency is fine. To find the frequency, you take 2 pi and divide by the period. And what that tells us is it is the number of full waves in the interval from 0 to 2 pi. So if a certain wave has a period of just pi, then it would have a frequency of 2. So that we get 2 full waves in every interval that is 2 pi in length. Excuse me. And then the last one is a phase shift, and that is a shift left or right. I know with our other functions we had, we didn't really have names for them other than a phase shift was just a translation. An amplitude would have been a stretch or shrink. Bias would have been another translation. And we really didn't talk about frequency just because, or period, just because our graphs didn't necessarily repeat the same pattern. So pretty specific for trigonometric functions. So let's take a look at just a general sine graph, and we'll look at these specific values. So this is the sine wave, and the graph here goes from a little bit less than negative 5 pi to a little bit more than 5 pi, and the y axis goes from negative 4 to positive 4. But what you can see is it has a maximum value of positive 1 and a minimum value of negative 1. And then we'll talk about the other pieces here in just a moment. But that's what the sine graph is going to look like. And then you can also see it does repeat itself. You know, we've got this part of the graph, that would be one period, 2 pi. Oops, I mislabeled this. Let me try this again. I mislabeled this part. Shame on me. This would be pi here and 2 pi here. So this would be pi over 2, 3 pi over 2, 5 pi over 2, pi over 2, pi, negative 3 pi over 2, negative 2 pi, negative 5 pi over 2. So sorry about that. And then the period was what I had highlighted. This is the period. You'll see it repeats that pattern over and over and over. All right, so for sine of x, the amplitude is 1. So the amplitude is always going to be the maximum value minus the minimum value divided by 2. The period in this case is 2 pi. The frequency, or angular frequency, would again be 2 pi divided by t, which is 2 pi divided by 2 pi. That's why we get 1. It was not shifted left or right. It was also not shifted up or down. So the phase shift and the bias are both 0. In general, if we know these pieces, we can write the equation similar to what we did before we got to the variation lessons. And that would be amplitude times sine of the quantity, frequency times x minus the phase shift plus the bias. And I'm going to add that symbol in here for the phase shift. I'm pretty sure that's the symbol that they use. So, excuse me. A couple of things. I'm going to go back to the graph here in just a minute, but we should be able to take any graph that is a sine wave and write it now, and we should also be able to determine all of these pieces. A couple of bits of hopefully review, maybe not. So for sine, at pi over 2, you get a value of 1. At pi, you get a value of 0. At 3 pi over 2, you get negative 1. At 2 pi, you get 0. And you can tell over here, I hope that you have the point 0, 0. So those are what I would call the kind of the main points on the graph in that first period. right. So here's what your homework is going to look like. Identify the amplitude, the bias, the period, the frequency, and the phase shift for each wave. Then write the equation. So here's a sketch of a sine wave. And what I am going to do is, excuse me, make a blank page and have both of them on the screen so that we can look at the graph and answer the questions. So I'm going to go with a blank page and go with a dual page display. So we want to find the amplitude, bias, period, frequency, and phase shift. Excuse me. So the amplitude, again, we take our maximum value minus our minimum value and divide by 2. So we get an amplitude of 4. Now, once you know the amplitude, you can figure out the bias. Okay? And what you're going to do is take the maximum minus the amplitude. So in this case, it would have a bias of 1. The period, and I just saw a little something I didn't like here. The period is how long it takes the graph to trace out one time. So in this case, it traces out from negative pi over 2 to pi over 2. So we take the x value at the end of one period minus the x value at the start of that same period. We would get 2 pi over 2, or just pi. So I'm just taking this value minus this value because that is how long the period is. The angular frequency is 2 pi divided by the period. In this case, the pi's cancel. So 2 is the frequency. In other words, you would get 2 full waves in every 0 to 2 pi interval. And the last thing is the phase shift. So in this case, instead of starting at 0, we're starting at negative pi over 2. So the phase shift is negative pi over 2. Whew. The last thing we're going to do is write the equation. And for that, I'm going to go just to the single page because I've got everything that I need to write that equation. we would get the amplitude for sine. And then we're going to take the frequency times x minus the phase shift plus the bias. And the bias up here was 1. So the only thing we don't need in writing the equation is the period. So if you're given a graph, that would be the way to translate it into the function. And again, very helpful to find those bits of information. The other thing you're going to do today is you're going to be given the equation and asked to find the different pieces and then draw the graph like this. So identify the amplitude, bias, period, and frequency for each wave, then sketch its graph. The one thing that they don't ask you to find in the textbook is the phase shift, although you could certainly do that as well. So I just wanted to point that out. And I don't know why they chose not to include that. All right. So the amplitude is not necessarily the number in front of the sign, but it's the absolute value of that number. So in this case, we would have an amplitude of 3. We just need to remember what that negative does in terms of changing the graph. The bias is whatever is added or subtracted at the end. In this case, there isn't anything added or subtracted, so the bias is 0. The frequency is simply the value in front of the parentheses in the sign. And then for the period, we'll use the fact that the frequency is 2 pi times the period. And so if we solve this for t, t would be pi. All right. So I'm going to label this graph a little bit. And the fact that I do have a phase shift, it is going to get shifted, and it is going to get shifted left pi over 4 units. All right. So in this case, the graph would go down 0. I just want to make sure I have that right, because it would be bad if it was wrong, and I should maybe label this spot in the middle. This is pi over 2. Yeah, that would be it. That would be the graph. So the one thing they may do to try to confuse you is, other than, having me teach, is do something like this, where the sign function isn't broken apart in the parentheses. So what you would need to do is factor out that value. And basically that means you're just dividing everything by 2. Again, amplitude, absolute value of this number that's out front. Bias, there's nothing added on the outside. Frequency, I guess I used a lot of 2s in this case for frequency. And when the frequency is 2, the period is pi. We have a phase shift of pi over 2 to the right. And so this one is going to go up, down, up, and that would be our graph. Homework. 443, 444. You're going to do 63A, 1 through 6. Do all 6 of those. Those, they give you the graph. They ask you to find those bits of information and then write the equation. And then 2 through 18, they give you the equation. They ask you to find the bits of information and then sketch a graph. The yearbook class, a yearbook committee, has asked me to remind seniors, if you haven't turned in your picture or your survey or those things that they need for the yearbook, do that by February 1st. So I don't think I saw any of your names on the list, or if they were, you were already contacted. So I think everyone in this class is okay.